So, in order for us to understand how the Earth works, it may help for us to take a step back, actually, a big step back, and discuss the formation of the sun. So, a caveat to all of this is nobody truly knows how the sun and the Earth were formed. But scientists over the past decades have been able to make their best guess based on research, measurements, and a whole lot of math. So here's what they've come to understand so far. Billions of years ago, there was a big cloud of dust that exists in the cosmos. This is not the only cloud of dust. There's probably tons and tons of these dust clouds just dispersed throughout the universe. But we're going to focus on the dust cloud that's closest to us in our solar neighborhood. So initially, this cloud of dust started to coalesce, come together, and eventually form this flat disk. This flat disk continued to pack itself tighter and tighter together through the force of gravity that just exists around us anyway. This disk eventually came to form the sphere that we now know as our sun. This giant sphere of energy eventually started to radiate gases, metals, rocks, and other structures that eventually came to form planets, exoplanets, asteroids, meteors, comets, all of that. But that all started from this dust cloud that eventually coalesced into a sun, whose sun eventually started to create byproducts from this dust cloud, which then started to coalesce and form a lot of the structures that now move and orbit around the sun. The same reasons why the sun started to condense in on itself from disk form into circular form is the same reason why our Earth and other planets rotate around the sun. And that reason is gravity. Gravity likes to pull things inwards. And if you gather enough mass as you pull inwards and inwards and inwards, what that does is it strengthens your gravitational pull. So the more mass you have, like a big, big, big sun, the more gravitational pull you're going to have. And when you have more gravitational pull, all these other neighboring structures have no choice but to fall in a circle around the big object. What's cool about this is we see this relationship happening between the Earth and the sun, the Earth moving around the sun. But we also have a similar relationship between the Earth and the moon. Because the Earth is so much more massive than the moon, and because the moon is close enough to the Earth to be influenced by its gravitational pull, the moon is also going to orbit around the Earth, very similar to how the Earth orbits around the sun.